Objective A. Simplify an expression by using the power rule. If you remember the power rule, it's talking about raising an exponent to another exponent. So let's say we have an exponent x to the a, and we want to raise it to another power of b. In this case, we simply multiply the two powers, and we rewrite as x raised to the a times b. Let's look at some examples. Number 1, 3 to the 5th squared. This one is a typical example of raising an exponent to another exponent. We simply keep the base and then multiply the exponents. 5 times 2, that is 10. Therefore, our answer is just 3 to the 10th. And you don't have to actually calculate what this value is. 3 to the 10th is already good. Number 3, m to the negative 5 squared. Apply the rules, we multiply the exponents. So write the base first, and then we multiply negative 5 by 2, we obtain negative 10. Usually, we rewrite our expression so that it doesn't have negative exponents in the final expression. That means we have to apply the rules for negative exponents. Or you could think about two-story apartments again. We're going to move it downstairs, so it's going to become m to the 10th. On the top, since no one's there, you simply put a 1. Objective B. Simplify an expression by raising a product to a power. Let's say we have a product x times y, and we're raising it to the power of a. You simply distribute this power into each factor inside and multiply the exponents. The two factors inside, both of them has an exponent of 1. So if you expand it, it's going to give you x to the 8th and y to the 8th. If you have a non-1 exponent inside, then you simply multiply that exponent by the exponent outside. Let's look at some example to illustrate this. Number 5. Notice we have 3 factors inside of the grouping symbol. Negative 3, a to the 7, b to the 4th. Make sure you mark the exponent for each of them. Negative 3 has a first exponent, a has a 7 exponent, b has a 4 as its exponent. So we're going to distribute this 3 inside and multiply each of those exponents. Let's write. First one, negative 3. Just remember that negative sign is part of the base. And then 1 times 3. So I'm going to show you all the steps. Second one, base is a, and the exponent will be 7 times 3. The third one, base is b. Exponent will be 4 times 3. And then you simply perform the operation. The first one is negative 3 raised to the 3rd power, and that is negative 27. Second one, a to the 7 times 3, that's a to the 21th power. Last one, b to the 4 times 3, that is b to the 12th power. Number 7. Number 7 is slightly complicated because you have a negative exponent outside. Well, you don't have to worry about it because we're going to multiply anyways. So follow the same procedure. Mark the exponent for each factor inside. We have negative 4 with an exponent of 1. We have p with an exponent of negative 3. Q with an exponent of negative 2. So you distribute this negative 3 outside, inside, and then multiply each of them by negative 3. Let's write. The first one, negative 4. Make sure to put inside grouping symbols. On the top, it's going to be 1 times negative 3. Next one is p raised to negative 3 times negative 3. And then q raised to negative 2 times negative 3. As a beginner, I highly suggest that you write it out, do it step by step. Do not do everything right away. Now let's calculate. The first one is negative 4 raised to the negative 3. And then you have p raised to the positive 9 and q raised to the positive 6. Let's calculate what negative 4 raised to the negative 3rd is. We could deal with the negative exponent first. Put it out downstairs. You simply have 1 over negative 4 raised to the third power. And then you have p to the ninth, q to the sixth. Leave them. If you calculate the numerical part, it's going to give you negative 1 over 64. And then you simply copy the variable part, and that will be your final solution. Alternatively, you could also put the variable part on the top. Rewrite as negative p to the ninth, q to the sixth over 64. Objective C. Simplify an expression by raising a quotient to a power. Instead of raising a product, sometimes you might need to raise a quotient. So the idea is the same thing. First, identify the exponents inside for each component, and then you raise each of them to the corresponding powers. So distribute the power A inside. Let's use an example to illustrate. Number 9, 2a to the 5th over b to the 4th raised to the 4th. So we have, if you consider this as a 2-story apartment, we have 3 tenants. You have 2, you have a to the 5th, and you have b to the 4th. For the first tenant 2, it has an exponent of 1, and the other 2 tenants' exponent are pretty obvious. The next thing you're going to do is you're going to distribute the power outside, which is 4, into every single tenant inside. Now let's calculate this. So on the top, it's 2 raised to the 4th, and then 5 raised to the it's going to be A is the base, raised to the 5 times 4 over B raised to the 4 times 4. Let's further simplify this. 2 to the 4th, it's simply 16. A to the 20th over B to the 16th. Number 11. Number 11 is pretty crazy. I would say you have negative exponents inside, and you also have a negative sign outside of that large parentheses. For complicated expressions like this, I highly recommend that you deal with the negative exponents first. The benefits of doing that is later on when you distribute the exponent 3 outside into the inside, it's less likely that you're going to make mistakes. So let's deal with the inside first. Copy the outside. So that's basically the structure of the apartment. And then let's check out each tenant and see what kind of exponents they have. First one is u to the negative 3. That's definitely a negative exponent, so I'm going to move it downstairs. U to the 3rd. And then v squared. V squared, I'm going to leave it upstairs because it has a positive exponent. So we're done with the top floor. Let's check out downstairs. Downstairs we have a 2. 2, it doesn't have an exponent. Actually it does. So there's an invisible one there. That means we're going to keep 2 downstairs. And then you have u to the 4th. That's definitely downstairs because it has a positive exponent. The next one, v to the negative 4. This one, we need to move it upstairs because it has a negative exponent. Alright, once we finish moving them, we're going to simplify what's inside. On the top, we're going to apply the product rule, keep the base, add the powers. Downstairs, same thing. Write down 2, and then keep the base u, add the exponents, we get 7. Outside, we still have a 3. And then we are ready to distribute the 3 inside. Remember, there is a 1 attached to 2. Copy the negative sign on the top. This time I'm going to multiply right away. So 6 times 3, that is 18. Downstairs, it's 2 to the 3rd, and then u to the 7 times 3, 21. Since 2 to the 3rd is a very simple number to calculate, I'm going to calculate that. So it becomes negative v to the 18th over 8u to the 21st. Next page, Objective D. Write a number in scientific notation or standard notation. Number 13. Number 13 is a scientific notation. So we have a number that's between 1 and 10, including 1, and multiplied by a power of 10. And that is a scientific notation. We use scientific notation to express very large numbers or very small numbers. If they want you to convert it back to the standard form, you simply move the decimal places either to the left or to the right. If the power of 10 is a positive exponent, it has a positive exponent, then you're going to move your decimal to the right. If the power of 10 has a negative exponent, then you're going to move the decimal to the left. For number 13, it has a positive exponent in the power of 10, and the value is 4, so we simply move the decimal point in the original number 2.06 4 times to the right. And that will be where the decimal is going to be. For the empty space, you're going to fill in with 0. Therefore, the first example right here will be simplified to 20600. Number 15. This is a very small number. As you can see, you have a lot of zeros after the decimal point. Again, it's a very good example to demonstrate how you could rewrite this in scientific notation. First, we're going to use all the digits that you see here to rewrite a number that's between 1 and 10, including 1. The only choice that we have in this case will be 7.41. So notice that I used all the digits. The zeros in front of 7, they don't matter in this case. Simply, we have 7.41. And then, you're going to figure out a power of 10, because that's how scientific notation works. How do you figure out what that is? So, there are several ways that you can do. The way I usually do is I look at the original number, and then look at the number that I pick right now. The original number is a very small decimal, and the number that I pick is 7.41. The number I pick is much bigger. That means if I want to go back to the original number, I have to move my decimal to the left several times. So my power of 10 has to be negative, because otherwise I will end up with a number that's even bigger than my number, and that's not what I want. Next, we're going to determine the actual value. How many times do I move to the left from 7.41 so that I can get the original decimal? Well, you could place the decimal into the original number. Let's say right here, right? We select 7.41, and then you test it out. How many times you have to move to the left? 1, 2, 3, 4, 5, 6, 7, 8, 9. Looks like we need to move it to the left 9 times. Therefore, the value here is 9. And the scientific notation reads 7.41 times 10 to the negative 9. So there is a little trick that you can use. The little trick requires you to count the number of zeros in the original number, including the 0 in front of the decimal point. So if you count these zeros right here, you will see that there are exactly 9 zeros, and that is the value that you're going to put on the top of your 10. One of the benefits of using Thai scientific notation is to perform complicated calculations, calculating operations between very large numbers and very small numbers. Let's use 17 and 19 to illustrate. 17, 3.7 times 10 to the 9th times 4.5 times 10 to the negative 2. To multiply scientific notations, it's recommended that you separate the numbers from the power of tens. By the commutative property of multiplication, if we reorder the numbers that we multiply, we don't change the results. So I'm going to switch the order of these two numbers right here. And I'm going to rewrite them as 3.7 times 4.5 times 10 to the 9th times 10 to the negative 2. Notice that I also group the new orders. That's by associative property of multiplication. And then we are ready to multiply. So let's multiply the first part. 3.7 times 4.5. Of course, you could use a calculator, but if you don't have access to a calculator, we're gonna do a multiplication. 5 times 7, that's 35 with a 3. 3 times 5, that's 15. Plus 3, you get 18. 4 times 7, that's 28. 3 times 4, that's 12. Plus 2, that's 14. And then we add them vertically, we obtain 5. Over here will be 16. This will be 5 plus 1, that's 6. And then you have a 1. And finally, we're going to add the decimal point. The original two numbers that we're multiplying, each of them has a 1 decimal point. Add them together, you have 2 decimal points. So you need to place the decimal point between the two 6 so that our answer has 2 decimal places. Therefore, it's 16.65. And then multiply by power of 10. So here we apply the product rule. Keep the base, add the exponents. 9 plus -2, that's positive 7. And then we're going to rewrite the result in scientific notation because it's required in the original problem if you read it. Therefore, for 16.65, we're going to rewrite using these digits as a number that's between 1 and 10, including 1. And that number is 1.665. And then we have to adjust this value because that's not the original value. This number that I pick is less than the original number, so that means that I have to move the decimal to the right. My power of 10 has to be positive. By how many times? Well, it's very easy to see that I only need to move the decimal point to the right once in order to get 16.65. So that is my exponent for 10. And I'm going to include the original power of 10, 10 to the 7th, and this is the expression so far. Finally, I'm going to combine the two power of 10s. Rewrite it as 1.665 times 10 to the product rule, add the exponents, 10 to the 8th. So that's number 17. Number 19. This time, instead of multiplying, we are dividing. So it's the same idea. Let's first rewrite them as a quotient. On the top, you have 5.2 times 10 to the 18. For the division, I'm going to rewrite it as a fraction. 2.6 goes downstairs times 10 to the 11th. And then I'm going to separate them. 5.2 over 2.6 times 10 to the 18th over 10 to the 11th. This step is optional. You don't really need to do this. You could just simplify straight from the original. But I think this is easier to see what you're doing. 5.2 over 2.6. If you have a strong number sense, you should see that there are two 2.6 in 5.2, so it simply simplifies to 2. Times 10 to the 18th over 10 to the 11th. By the quotient rule, we keep the base and subtract the power, we get 10 to the 7th. And that is your answer. Next page, 21. The area of South America is approximately 6.9 times 10 to the 6th square meters. Express this area in standard notation. So this time, starting with 6.9, we simply follow the power of 10s. Since the power of 10s in this case has a positive exponent, we're going to move the decimal to the right 6 times. 1, 2, 3, 4, 5, 6. And then fill in the empty space with a 0. Therefore, our answer in standard notation is 69 followed by 5 zeros. Alright, that's it for 5.2. Thank you for watching.